We can start, right? Good afternoon and welcome to our webinar today, Removing Pharmaceutical Micropollutants, Technical Insights, Policy Alignment, and Call for Case Studies. This is hosted by Water Europe, the European Water Technology Platform, and is organized by the Water Europe Expert Group, Zero Pollution Health. And of course, tons of thanks, to the expert groups and its members and experts for organizing this webinar today, which is an opportunity to bring together a diversity of concerned stakeholders around a pressing challenge, which is in water management, which is, the presence and removal of pharmaceutical micropollutants in the water systems. As we know, pharmaceutical substances, could be antibiotics as well, hormones and other active compounds can persist through the conventional wastewater treatment processes and can enter into the aquatic systems and environments with a potential impact on the ecosystem and human and animal health. And addressing this issue requires not only technological advancements, but also regulatory alignment, financial feasibility, and at the end of the day, real-world capacity of validate innovation. So the webinar is designed in order to be interactive and collaborative, and our speaker will set the scene, present the structure, the emerging insights from, we'll see, the technical paper, and highlight the importance of data and real-world case studies, and engage, of course, with live interaction and discussion. So we want really to exchange, to share knowledge, but also to strengthen the evidence, which is about, the necessary alignment between technical innovation and policy evolution at the European level. And but before handling, starting the core area of the webinar, I would like to briefly introduce Water Europe. Water Europe is the European Water Technology Platform. It's the recognized voice and promoter water-related innovation, research and technology development in Europe. Nowadays, we count on more than 275 members, close to be 300 members from 31 countries, representing 1 million employees with a turnover of 232 billion euro. The mission is to improve the coordination and collaboration in the water ecosystem in the European Union and beyond the European Union through different kind of international connection and cooperation, enhance performance and competitiveness of the whole water ecosystem, and of course, contribute to address and solve the global water challenges through research, innovation, technology, and other actions. So it's a multi-stakeholder association representing, the full value chain of the water sector and related sectors, and we have, one vision driving the association as a purpose-driven organization. Okay, next. So our main approach is to promote the achievement of water smart society and economy in which the value of water is recognized, and in order to ensure that, as you can see, there are three important areas: water security, sustainability, and resilience are ensured. That all the available water, all the pollution from water is avoided, and water resources are managed, that water scarcity and pollution are largely close to foster a circular economy and an optimal resource efficiency. In this scenario, all relevant stakeholders are engaged in guaranteeing sustainable water governance. Next, please. In this scenario, in this organization of Water Europe can count on the activities of 15 expert groups, which are made by the members of Water Europe, and we have grouped them under three main categories. The five expert groups working in the area of water security, so about quality and quantity. Other five, under the umbrella of water sustainability, which looks at the governance and market of the water sector, and the last but not least group, under the thematic area of water resilience, which is about management and the environment. The webinar today is organized by, the expert group on zero pollution and health, at which once again, I mean, I want to really to extend, I mean, our sincere thanks. And today, I mean, it is joined by an important number of experts. We can start with Blanca Antizar, which is currently on sabbatical and visiting professor at University College London. She's the co-chair of the Zero Pollution and Health Expert Groups of Water Europe and the leader of this technical paper. Angeles Blanco, she's the professor of the Universidad Complutense de Madrid, member of the Zero Pollution and Health Expert Group and co-leader as well, I mean, for the realization of the technical paper. Olga Ferrer, Desalination and New Technology Area Manager at Acciona, member of the Desalination Expert Group. Stevo Lavrnic, Associate Professor of the University of Bologna, member of the Green-Grey Infrastructure and Other-Based Solutions Expert Group of Water Europe, and Alan Mestet, Managing Partner of H2 Vortex and co-leader of the Water and Finance Expert Group of Water Europe. So I'm really happy that we are all here today. I think that will be a great webinar. And I'm very pleased, I mean, to hand over the floor to Blanca to introduce the topic and the webinar in more details. Thank you so much.
Okay, so thank you very much, Andrea, for this kind introduction, and thank you also to Water Europe for hosting this session today. The work in the Zero Pollution and Health Expert Group is rooted in 4 priorities: advancing knowledge on zero pollution pathways, supporting policy alignment, promoting safe, resilient and circular water systems, and contributing to the Water Smart Society vision, where the value of water is recognized and realized to ensure water security, sustainability, and resilience, as Andrea has mentioned already. Today's webinar is part of that mission, and we have come together to announce the work we are doing on the first technical paper focused on the pharmaceutical micropollutant removal in wastewater. Our session is intentionally interactive. I will begin by setting the scene and walking you through the key insights of the technical paper. After that, Angeles Blanco will take us into the methodology and case studies, and we will close with a panel discussion and your feedback. Your perspectives today will directly shape the final version of this paper. So it's very important that please you all contribute to that today. So let's start. Why pharmaceutical micropollutants matter? So pharmaceutical micropollutants are not new, but the urgency around them has changed. We now detect these micropollutants at nanogram levels across effluents, rivers, groundwater, and even drinking water. Many pass through conventional treatment unchanged because of their low absorption, low biodegradability, and high polarity, among other properties they have. Their impacts are ecological, chemical, and microbiological, including their contribution to antimicrobial resistance. This is a One Health issue connecting humans, animals, plants, and environmental health, and therefore addressing them requires coordinated action across the entire water cycle. We are at a crucial moment in Europe. The revised Urban Wastewater Treatment Directive introduces mandatory removal of pharmaceutical and cosmetic micropollutants, extended producer responsibility, energy neutrality by 2045, and reinforced monitoring requirements. And just last week, the General Court confirmed the legality of the EPR mechanism, giving member states and utilities the certainty they need to move forward. In parallel, the European Water Resilience Strategy pushes us towards circularity, reuse, and climate adaptation. Together, these frameworks create a window of opportunity to rethink wastewater, not as a liability, but as a resource. And this is why we at the Zero Pollution and Health Expert Group are now working on this technical paper, which reflects this integrated perspective. In the paper, we begin with the policy context, then review the most promising treatment technologies and include other emerging or low-carbon solutions. We explore how these contribute to water resilience and circularity, and we close with implementation challenges, research needs, and a vision for 2050. Case studies and synergies with other expert groups to bring an integrated perspective are also included in the paper, and they are in particular the focus of the webinar today. The starting point in the paper is the limitations of conventional treatment, including secondary biological processes like activated sludge or basic tertiary treatments, which alone cannot meet the new requirements. Typical removal rates range from 20 to 60%, depending on the microcontaminants we are targeting. And many pharmaceuticals are simply too persistent. This is why advanced technologies and quaternary treatment is now essential in our wastewater treatment plants, not optional, if we want to protect ecosystems and comply with the revised directive. As today, there is no single best technology. Promising options include adsorption, such as activated carbon, advanced oxidation processes, such as ozonation, and filtration technologies, including membrane systems. Emerging or low-carbon solutions, such as nanobubbles, electrocoagulation, nature-based systems, or enzymatic approaches, offer additional pathways, especially where energy neutrality or resource recovery are priorities. In many cases, hybrid systems are needed to achieve a broad spectrum removal. The right choice depends on the existing plant configuration, the effluent quality required, and the potential for water reuse, among other specific conditions and requirements. Our goal in the technical paper is to provide a balanced, evidence-based comparison of these treatment options. In the technical paper, we undertake a systematic study for all the promising treatment options and identify the pros and cons of each one of them. As an example, membrane systems, particularly nanofiltration and reverse osmosis, are highly effective for removing recalcitrant microcontaminants. They use limited chemicals, they are modular, and can be used for both centralized and decentralized applications. They are also becoming of increasing interest for effluent reuse for high-quality uses. But they also come with challenges. For example, higher operational costs, although this would depend on what are we comparing this with, membrane fouling, pretreatment needs, and the management of the concentrate stream, and end life of membrane management. As membranes age, increasing transmembrane pressure also contributes to operational costs. And as you already realize, these are important trade-offs when considering large-scale deployment. Our technical paper highlights that advanced treatment is not only about compliance, it is a cornerstone of Europe's water resilience and circularity goals. Briefly, speaking about water security and reuse, membrane systems enable high-quality reuse, while ozonation, adsorption, and other emerging technologies support safe reuse for agriculture, urban applications, and industry. Yet, less than 3% of wastewater is reused in Europe today. Considering climate mitigation, integrating advanced treatment with energy optimization and resource recovery can reduce greenhouse gas emissions. This is why low-carbon technologies, including enzymatic systems, offer promising pathways towards the 2045 energy neutrality target. Considering circularity, wastewater contains a valuable amount of resources, including water, nutrients, organic matter, and energy. When treatment plants are designed as resource recovery facilities, this can be reclaimed and reintegrated into the economy. And finally, the socioeconomic acceptance plays a key role. Costs increase, but long-term benefits, which include avoided pollution, improved health protection, and resource recovery, outweigh them. The extended producer responsibility will also ensure that polluters cover most of the costs. And we realize that moving from ambition to implementation brings several challenges that also need to be addressed. Scaling emerging technologies, as many solutions perform well in labs and pilots, but require major investments and operational adaptation at full scale. Monitoring and quantification as trace level detection requires advanced analytical tools, but also specialized staff and harmonized methods. Life cycle and techno-economic assessments as transparent, comparable data is essential for decision-making. Transformation products and toxicity, as we know that removing a parent micropollutant does not guarantee safety, and byproducts must be understood and monitored. Also policy and funding, as we need regulatory certainty and targeted financing, which are critical for innovation to scale. and also digitalization. Digital twins, artificial intelligence, and smart control systems can optimize performance, but adoption is still limited by data and skill gaps. In summary, these challenges highlight that implementation is not only technical, it is also analytical, financial, regulatory, and digital. Our long-term vision reflected in the technical paper is water without traces. By 2050, we envision a Europe where water flows clean of pharmaceutical micropollutants, supporting public health, vibrant urban ecosystems, and resilient biodiversity. This future is energy neutral, circular, digital optimized, and fully integrated with water reuse strategies. It requires upstream action, better product design, and a deeper understanding of how contaminants move through our system. And it depends on collaboration across regulators, utilities, researchers, and communities. This is a very important reason why we're all here today. Okay, so now is when we start our interactive session, the first one. And before we move into the next block, we would like really to hear from you, the audience. Your feedback at this stage is very valuable because it helps us refine the technical paper and make sure that it reflects the realities, priorities, and needs across the sector, not only those that we see. You can see if you click on the link on the screen or you use the QR, an online form that can be accessed very easily, either on your laptop or on your mobile. It should only take you a few seconds, and your input will directly shape the next iteration of the work. Use your laptop, please. Use your mobile right now as you keep joining us on this webinar today to open the form and select your answers now. In a few minutes, we'll look at your results and we will share them with you. The first question asks, which section of the paper is most relevant to your work? You might select on the questionnaire, on the online form, more than one option. And your input will help us understand where the paper needs to go deeper and where we may need to clarify or expand. The second question is, which technology should we prioritize for case studies? And again, you might select more than one of the options in the form. And this is essential for us because the case studies will form the backbone of the evidence base in the final version of the paper. So please tick the boxes on the form and we'll look at the preference in a few minutes. Thank you. And now we are going to move to the next block of this webinar presented by Ángeles Blanco, which is going to focus on the data analysis and the further quest for case studies that we are going to use to validate the empirical models being deployed. Ángeles, the floor is yours.
Thank you, Blanca. As Blanca has explained very well, we are here today to ask for your help. And with these case studies, the main aim is to predict the efficiency of quaternary treatments for micropollutants removal. So it's not an easy task because the first idea is to know which are the best treatments and then what do they remove, how much, the conditions, the cost, etc. So when we were comparing all the treatments which are studied at the moment, at the end, someone asked that we should have a kind of table in which we could predict which contaminants are going to be easily removed by the different technologies. So kind of we wanted to classify them in green when they are removed by a given technology, or in red if they are not going to be affected by that technology. But what we have found out is that to make that kind of a prediction tool or table summarizing all the knowledge from experts, different experts, is not easy. So what we tried to do, it was based on the state of the art, in which we found out that there is a very big data fragmentation, in which we can find the study of different micropollutants at lab scale, pilot plants, or wastewater treatment plants, and all of them work with different water matrix, not only with effluents from real biological treatments. And there is also a lack of harmonization in the treatment conditions. So we are here to call for help. We need data from wastewater treatment plants in order to validate the prediction tools, and that is the main aim of the case studies, in which you can provide with treatment conditions of any technology or different technologies, and then what is the micropollutant efficiency removal. So how we have addressed this prediction tool methodology. So we have a study at the moment. We are comparing active carbon with ozonation, and the prediction tool is based on the properties of the micropollutants. So for each micropollutant, we have we can determine, we know the structure and the properties of that micropollutant. We identify the structure characteristics which may enhance or hinder its removal by absorption or by ozonization. Then we know the potential removal mechanism. From that, we can give a prediction value. But this is a mechanism-based prediction value. So it doesn't mean that micropollutant is going to be removed in a wastewater treatment plant by a given treatment. So we need to validate those data, comparing the predicted value with published data about removal efficiency. With that data, we have adjusted the model. But what we have found out is that in the scientific reference, most of the times we have a lot of lab results in which the TRL is relatively low, between 4 and 6, and that may overestimate the real efficiencies when we try to remove that contaminant in a complex matrix. And we also found a very high variability in the experimental conditions. So we have carried out a second validation step in which the optimized predicted value, we compare it with cases of higher TRL 7-8 from case studies in wastewater treatment plants that has been already published. And we have adjusted the model based on those data. But again, we have found out that there is a competition among pollutants in real wastewaters which alter the efficiencies. So where are we now is that we are going to have a third validation, and that is why we need your help today. We want to compare these adjusted predicted values with case studies which have a high TRL 8-9, so that we can readjust the model again. So I will show you a bit more in detail how we do this, for example, for the active carbon absorption rank. So in this case, we have 4 main parameters which are important to determine if for a given micropollutant is going to be easily absorbed or it will not be absorbed. The first parameter will be the hydrophobicity, and that is easy to calculate based on the partition coefficient data in octanol and water. We also consider the interaction potential based on the PV interactions with the carbon domains. And then we have to consider the hydratation, so how polar could be that product, and also the structure and the geometry and the molecular size of the micropollutant that will give us information about the micropore accessibility. So based on these 4 parameters, we can give a mechanism ranking in which we can order the different compounds from 8 to -5 points. But with this information, it doesn't give us a good idea if these compounds really are going to be removed or not in the wastewater treatment plants. So we have validated all these data. As I have mentioned, we have already carried out 2 validations, and where are we now is that in this slide, we can see that in green, we have all the compounds which are really removed by absorption in many wastewater treatment plants according to reference that we have got. So in red, in the bottom of the table, we see the ones that are not going to be removed, which you can see in the PCA analysis and the principal component analysis that all the compounds which are in the right side will be easily removed because they are hydrophobic and they are accessible, while on the contrary, we have all the ones which are have to be desolvatation first. It will be more easily to be removed, or when they are not, they are too big to enter into the nanopores. So this is how we adduce the data, alpha, beta, gamma, and delta, the coefficient of each of the properties which are affecting the absorption in this case. And we need further data to further optimize these coefficients in order to be representative for a higher number of products. So in the next slide, we see how we calculate the index of the micropollutant reactivity towards ozone. In this case, it's a bit more complex because we have more parameters that influence in the capability of ozone to degrade these different molecules. We have the first one is the direct molecular ozone reactivity. That is easy to calculate based on the number of double carbons that we have and the number of activated aromatics, for example. Then we also have the other parameters like the aromatic electronic activation that will facilitate the direct ozone attack. But we have other parameters like the stabilization filters, that they are elements that hinder fragmentation. For example, when we have amides or heteroaromatic rings, we know that those compounds will be refractant to the ozone attack. We also consider the structural accessibility of the reactive centers, which is specific for each compound based on the geometry of the micropollutant. We consider the indirect potential to be attacked by the radicals, and we also consider the potential fragmentation. So how easily will be to have transformation products. Based on that, we do the same study than before, and then we can see in the next slide the table, which is in white. We have classified our compounds with a given rank, and then we can classify in colors. After the validation, we see how they are in green, the ones which are easily removed by ozonation, and in red at the bottom of the table, we see that the ones which will be recalcitrant to ozone. So if we look to the principal component analysis, we see that in the right, we see we have the easily removed compounds because they can have a direct attack, they have activated rings, or we have on the other side in the left, the ones which are stabilized and they are low accessible, and then they will not be removed. So they will be recalcitrant to ozone. So what happened then is that when we compare the what is the removal efficiency of the different compounds by ozone or by activated carbon, we see that we have in green a few compounds which are removed by ozone, but they are not removed by active carbon, and also the opposite. They can be removed by active carbon, but not by ozone. So that means that, as we know, a single technology does not achieve an efficient removal of all micropollutants, and a combination of technologies will be necessary in order to assure a wider range removal of micropollutants. And because we can combine technologies in different ways, we can optimize doses and we can reduce the cost, and we need to valorize the synergic effect between technologies, because we can have first ozonation. We know that we will have some negative negative things. There is nothing perfect. We will generate some transformation products, we will generate some bromates, but we could absorb those with the active carbon. And we can also combine technologies like in the table where we compare ozone with nano-ozone. And we can see that with nano-ozonation, which is an emerging technology, we can significantly decrease the total concentration of ozone that is required to remove 80% of these micropollutants in real wastewater. So that is also something that we need to further explore. But what is clear is that if a component is not removed by ozonation, it doesn't matter if we have microbubbles or nanobubbles, it will be recalcitrant. So in the next slide, we show the main challenge for the optimized efficiency of quaternary treatments. We still have a lack of harmonized data. We need effluent quality. We need to know the micropollutants which are present, the dissolved organic carbon, and the suspended solids, and then also the treatment conditions in each case, like the dose, the time, etc. We have a lack of standardized data set, so that means that the comparison between technologies is difficult. We need to valorize the synergic effects between technologies. And the key data for the micropollutant removal efficiency in real wastewater, urban wastewater, we need this data to further validate the prediction tools. I have shown you these two examples today, and we want to reduce the uncertainty, and we want to increase the result reliability in order that we get realistic and representative micropollutant efficiency classifications that we can give some tables that will help you to decide which is the best technology for your specific wastewater treatment plant. And with that information, we can also optimize conditions in order to reduce the cost while maintaining efficiency. So, Blanca, maybe you continue with what we are looking for now in the case studies.
Okay, thank you, Angeles. So yes, let me emphasize before we do that what we are actively looking for as we finalize the technical paper is case studies. So to build a robust and representative evidence base, we are seeking case studies from across the sector, from utilities, SMEs, research projects, and other expert groups. We are particularly interested in examples that are high TRLs. They involve promising treatment technologies combined or not with the use of emerging or low carbon technologies, digital tools, monitoring approaches, and also co-benefits. For instance, pharmaceutical micropollutant removal is achieved along with the removal of, for example, PFAS, microplastics, or other priority substances. The goal for us is to capture the diversity of real-world conditions across Europe, different water matrices, different plant configurations, and different operational constraints. These case studies will help us validate the prediction tools that Angeles has presented, strengthen the comparative analysis, and ensure that our technical paper reflects practical implementation realities. So here we have the second Google form that we would like to share with you. So again, as before, please use the link or the QR to get access to this form. We'd like to emphasize that we already have a number of promising examples of case studies, but we want to broaden the picture. Whether you have a full-scale installation, a pilot, a research project, or even early operational insights, will very much welcome your contribution. Please take a moment to fill in the online form that can be accessed by scanning this QR code on the screen. See also the link in the chat. Please leave us your contact details in the form so we can reach you for further information after the webinar today if necessary. This form might take you some more time. We want to simplify it. If we want details, we will contact you after the webinar, because at the moment what we want to identify is the case studies that we can integrate in the technical paper. As Angeles has mentioned, what we want to gather is more data to validate the empirical models. So please include this data in the form, and also please be reassured that will take into consideration any confidentiality concerns or requirements that you might have when you share it with us. Yeah? So if you open the form, you will see all the questions. It should be straightforward. It shouldn't take you more than 5 minutes to fill it up. So please help us with that. And also this will be a great opportunity for you to give more visibility to the work you are doing.
Yes, and it's important also to mention, Blanca, that this data can be confidential if you wish. So you just tick the box of that you want to keep it confidential. We will only use it in that case as aggregated data to validate the models, but we will not distribute or we will not give any more information about anything if it's confidential. But you can also, you may prefer that these data are in the annex of the technical paper, and then we will organize it and we will make, it can be part of the annex. But it's also important that not everything will be in the annex. We can keep it confidential. So if that is the case, you can contact us, send the questionnaire, and we will keep it confidential.
Yeah, great. So then, thank you. I'm going to share now some of the feedback that you have already provided and share with us. Let me remove the laser pointer from my mouse, if I can. So what we are going to do is we are going to share with you this other screen. So you can see some of the feedback that you have already provided to us. So as you can see, it looks like you are the most interested or the highest interest is on the promising treatment technologies. And this is great because this is very much aligned with the approach that we are taking. And we want to focus on the identification of what works, what doesn't work, that has already been tested. Summaries of your case studies also will be introduced there. And then in terms of technologies, the one that is showing here highest interest is the advanced oxidation processes as well as activated carbon. Equally important, you are also interested in the combined approaches, the role of nature-based solutions, and the use of membranes, which is great because we have experts here in the panel later on that are going to help us understand some of the opportunities there. But also you have highlighted other technologies. So be reassured that we'll look in detail to everything, all the feedback that you have provided, and we will include that and address that in the presentation of the final technical paper. So going back to the slides, we are going to go back to this screen to continue with the presentation. And for that, we are going to move to our panel discussion. So I have the pleasure today to welcome and thank as well representatives from a number of expert groups of Water Europe. They are the desalination, the grey infrastructure and nature-based solutions, and also the water and finance expert groups. Thank you all for being here. Particularly thank you, Olga, thank you, Estevo, and thank you, Alain, for joining us today. As you know, your views and inputs are very important because pharmaceutical micropollutants sit at the interface and of advanced technologies, nature-based approaches, financial feasibility, and many others. This dialogue today is going to help us immensely to refine the paper and ensure alignment across Water Europe's technical outputs. We are exploring more synergies as well with other expert groups beyond the 3 represented today, because we want to be inclusive. We want to listen to everyone. This is our purpose today, and I would like to take this opportunity to invite also the audience to write the questions you have for the panel on the chat. So we are going to start with the first round of questions, and then we will address the questions that you have from the audience. So please start using the chat, and Angeles is going to help me to identify what are the questions that we are going to be able to prioritize and answer today. So before we kick off with the panel, I would like to go around the table. So you can take each one of you, Olga, Stevo, and Alain, 1 minute to introduce yourselves, role and expertise, and then we'll kick off with the first round of questions. So please, if I can start with Olga, the floor is yours.
Thank you, Blanca, and thanks for the invitation. As Andrea said, my name is Olga Ferrer, and I work in Acciona in the R&D division, leading the desalination and new technology areas. I'm chemical and industrial engineer, and my background is on membranes, mainly where I did my PhD on ultrafiltration and reverse osmosis for drinking water production. And during the last 8 years, when I joined Acciona, I started to work mainly on desalination, so using membranes for such purpose. And here is where the link comes with the working group of desalination, because as you already mentioned, membranes can help with the elimination of emerging contaminants.
Wonderful. Thank you very much, Olga, for being here today with us. And now we move to Stevo Lapner.
Yes, hi, thank you for your invitation. It's very nice to be here. Stevo Lavernic, University of Bologna in Italy. I'm associate professor here, and I'm working on HEB solutions for water purification and treatment. I'm also working on sustainable water management in agriculture, including water use and risk management. And the micropollutants are something that is emerging topic, definitely also when we are talking about nature-based solutions. So I'm happy to give my contribution.
Wonderful. Thank you, Stevo. And last but not least, Alain Mestat, please.
Well, thank you very much for providing me here with the opportunity to provide some input. Alain Mestat, based out of Luxembourg. I'm a former investment banker, so I bring the more financial aspects into the discussion. And I was previously mentioned by Andrea, I co-lead the Water and Finance Expert Group within Water Europe. Thank you.
Wonderful. Thank you very much. So then we are going to start with the first round of questions. So if I can start with Olga, and this will be questions about the role of membrane technologies as one of the advanced or more promising technologies that we have identified. So from your perspective, what are the most critical operational or design factors that determine whether membrane systems, especially nanofiltration and reverse osmosis, are viable for large-scale pharmaceutical micropollutant removal?
That's a complicated question, Blanca, to start with, because the removal of emerging contaminants depend on many factors. So in the physicochemical properties of the contaminant, like the size, the charge, the hydrophobicity, etc., the concentration, also the metrics quality, like the pH of the water to be treated, the ionic strength, also on the membrane characteristics, not only if it's like high pressure or low pressure, but also the hydrophilicity that it has, the fouling status, and also the operational conditions, so the pressure, the recovery, whatever. So it's very difficult just to give like a single answer, but what it's clear is that high pressure membranes, and especially reverse osmosis, are good candidates to remove emerging contaminants, and you are able to remove them so that the permeate is free in most of the cases of them. But in my opinion, membranes, as you already said, they should be combined with other processes. So for example, if you use reverse osmosis, you can, thanks to it, concentrate the pollutants and then treat with oxidation or adsorption, a lower volume, so that probably economically it will be cheaper, and you can distract these compounds in situ, so that you would have like the permeate free of them, but also the retentate. So I would say that it should be studied case by case, because also maybe you prefer like to focus and have nanofiltration that have lower rejection, but maybe combine it in the permeate with advanced oxidation. So it's quite complex, and I think that it should be seen case by case, or maybe in group of cases, depending on the contaminants that you have and the target removals.
Okay, wonderful. And where do you see the biggest evidence gaps that our technical papers should address to guide the utilities in making informed choices?
I think that for what I've seen so far, it's great. I mean, you're tackling the key topics, and also with all the feedback that you're receiving, it will be super interesting. My recommendation maybe would be to set some objective metrics. So what is high removal? So like to put some percentages of medium removal of each component. And this could help the comparison, so that depending on the concentration that you have, just to see what would be the best technologies. Also, what is like high or low energy consumption, maybe like putting some ranges, maybe not absolute values, but in comparison, so that you can decide if you prefer to go to oxidations or adsorption of membranes. I think that that would be helpful for the people, because as we have seen, one of the key expected outcomes is which are the best technologies, so parameters to enable their comparison. Maybe also, if in some cases there are some key success factors, so like what is a parameter that you should take into account that enables the implementation, or maybe limits it because it doesn't work. And finally, I think that bringing together these case studies will be super interesting for people that are now thinking, what should I put? So if you have like some examples, you can see or feel more comfortable on the outcomes that you can expect. Also the requirements in terms of operation, in terms of site footprint that you need, even maybe a contact point in case they want to know, hey, how has this gone? So maybe that would also be interesting. And for sure, these predictive tools that Angeles was explaining, I think it's super useful if you can make it for each technology to help to make the selection.
Yeah, wonderful. And thank you also for the feedback on the tool. Yeah, and Angeles, more work for you. Yeah.
Yes, I
Yeah,
have a question also about if we have membranes results. We haven't applied the tool to predict the behavior of membranes, because that is relatively easy, because it's based on the size of the membrane, the contaminants, and the absorption properties. So in principle, we know what with the right combination of membranes, as Olga has said, we can remove most of the contaminants. And the problem is sometimes that we remove too much something and too less of another. So the compromise is difficult, but it is possible, and that is why these membrane technologies are being used in many cases, especially when reuse is a priority for high water quality, like in industry, high quality, or in direct drinking water, or cases like that.
Yeah, exactly, because they allow also removing like the salts that some
Exactly.
applications they require to have low conductivity. So that's an additional, let's say, advantage of these processes.
Yeah, excellent. So now we are going to move to Estevo and nature-based solutions. So the question that we have is about nature-based solutions are increasingly discussed as low-carbon complements to advanced treatment and highlighted. People want to know more about that in the feedback that we have received today. In your view, what specific nature-based solutions could be used for the micropollutant attenuation?
Yes, it's as I said before, it's definitely emerging topic. So there are different studies that are oriented to removal of micropollutants by nature-based solutions. In my view, I think that mostly the systems that can provide filtration, so the systems that have a certain substrate with a certain characteristics, so they can combine filtration, sorption, and other other removal processes are the most suitable. So it also depends on the type of water that we want to treat. So if we talk about domestic wastewater, then I would say constructed wetlands, especially subsurface flow ones, since they can provide substrate filtration. On the other hand, I don't think we should forget also agricultural runoff, because it also contains different pollutants that are often overseen and that can increase pollution of surface water bodies. So in the case of agricultural runoff, I would go for, I would say more buffer strips. So again, the systems that have certain vegetation types and certain substrate that can stop agricultural runoff flow towards surface water bodies and remove certain contaminants. I think it's also important to let's say consider nature-based solutions that can provide a certain hydraulic retention time, since natural processes are more slow, usually more slow than other human-induced processes. So it should be the systems that can provide specific hydraulic retention time that would be necessary for the removal of certain contaminants.
Wonderful. And yes, nature-based solutions were not developed in principle to remove pharmaceuticals. We are seeing now that they can play a role because of the targets of low carbon or net zero by 2045. But also, as you mentioned, some of them may be able to reduce some of the loading of some of the target micropollutants, including micropharmaceuticals. So from your point of view and from what we have presented today and what you have seen, what should we capture in the paper to ensure that nature-based solutions are assessed realistically and not idealized?
Yes, I agree. I agree with that approach. I think we all have our fields of expertise, but we should be aware of the limitations of the solutions we are working on. I think nature-based solutions can provide different benefits, and they can be used also, as you said, they weren't developed specifically for micropollutants, for emerging contaminants, but they can also play a role in that sector, usually combined with other types of treatment. Obviously, depending on the types of polluted water we have to treat. So I think to assess them realistically, we should look for since they're nature-based solutions, they're very temperature dependent. So we should really look into the effects that temperature can have on removal processes. Does it depend on season? Does it depend on the time of the year and so on? We should also see how micropollutants removal behaves during peak flows. Nature-based solutions are very flexible in that sense, so they can treat variable flows of water, but it might compromise at the same time removal of specific contaminants. So we should also look into that. Land requirements are one of the negative points definitely in nature-based solutions, since they might require big surface areas to provide certain contaminant removal. So it's something that should be looked at specifically for micropollutants. Then I think it's also important to see how the media, how the substrate behaves over a long period of time. So for example, constructed wetlands, they have a certain substrate that might get saturated after some while. So it's important to see how that aspect works for micropollutants. But then I also think we should definitely check the overall trade-offs, let's say. So nature-based solutions can provide different benefits as well. They are low-cost systems. They are systems that can really help with the biodiversity development. They are low maintenance systems. So it's important to look at the whole picture, I would say. Again, not specifically to nature-based solutions. I think all the solutions we apply, we should be more aware about their general sustainability. So I really think the nature-based solutions can have potential in this area, considering all the aspects.
Okay, wonderful. Thank you, Estevo. This has been really good thoughts that you have shared with us based on your expertise. Thank you. So now we are going to move to the next question, Alain, about on finance and implementation. So the revised Urban Wastewater Treatment Directive and also EPR created strong drivers, but implementation will require major investments. From a finance perspective, and based on your expertise and knowledge, what are the most important enablers or barriers you see for scaling quaternary treatment across Europe?
Well, when you talk about finance, and in particular in the spectrum of water, usually the person talking about finance in that realm is usually bearer of difficult news, because when you work as an entrepreneur, you will always look at, let's say, return of investment. So there's a financial gain component, which is clearly important. What we've seen here with additional regular constraints, that is certainly helping to frame the whole process. But we have to make a distinction between public and private initiatives. On the public side, it's a lot easier in that sense to implement. But now with the regulatory control, yes, there is more scrutiny in terms of, let's say, the requirements to do that. But in the end, private companies are going to have to do an analysis of what is the cost. And unfortunately, as water does not necessarily carry a cost, one of the things you need to look at, in particular with these contaminants, is actually, as what I would qualify, significantly strengthen the economic narrative around avoided cost. What are those avoided costs in the end? Those can be, for example, healthcare costs. So in that individuals are becoming more resistant in terms of health issues. So all of those are factors which need to come in. And at one point, as we've seen in the presentation, you need to be able to quantify those, because once you have quantified those, it's easier for private enterprise to actually look at the pros and cons, look at the potential penalty, and then act in that sense to make sure that these directives and even further are implemented in the right format.
Okay, wonderful. And there's a lot happening now at European level in terms of blue bonds and different mechanisms, models that we are hearing about. And so I think that what it would be good for the technical paper, and I'm sure that the audience is very interested in today, is about what are those financial models or incentives that we should highlight in the technical paper to support the utilities and also the SMEs through this transition of implementing the quaternary treatments.
In that sense, blue bonds are, let's say, an equivalent process as we have already known for many years in terms of green bonds. So it's the idea to be able to finance sustainable initiative with one dedicated process, but a process which have been scrutinized from a governance point of view. So we would like to avoid, of course, the whole notion of greenwashing or blue washing in that sense. So the blue bonds can only work ultimately if you have a financial revenue flow. It's the same thing with any type of financial expenditure. You have let's say, a capital which needs to be repaid in form of coupons. Coupons will need to be repaid in terms of having recurrent revenues being generated. So in that sense, it is important to create this framework, certainly in this particular case, where water reuse is important, and the water reuse has to be able to have a cost attached to that in order to make sure that the financial mechanism is working adequately.
Okay, thank you. So now we are going to move to the audience, and we are going to be looking at the questions you have been asking in the chat, and we'll select a few. You know, we are always limited by the times. We'll select a few that we can ask to our panel.
Yes,
so yeah, Angeles, do you have the time to select a few questions?
Yes, there are a few questions. Actually, we have a quite quiet audience. They are not making too many questions. Maybe we are really clear, as transparent, clear. But there is one very interesting question about if we can apply this knowledge to different wastewaters, like, for example, to treat contaminants at source, like in the wastewater from hospitals. So I may start answering this question. Yes, in the technical paper, we are comparing different technologies, and that information with the pros and cons can be applied to different cases. And if we speak about the prediction models, then the validity of that models depends on the we have been working with a number of micropollutants. At the moment, we have used 60 different micropollutants, including the 12 in the annex of the Wastewater Treatment Plant Directive. And if we get new pollutants which have a totally different structure, then the fiability of our prediction will be lower. But at the moment that we validate with real data from hospitals, then we will increase it. So it's a question of adjustment of the different constants, the alpha, beta, gamma I have shown in the slide. If we adjust that constant for different cases, then it will be useful. But since the models are mainly based on the properties of the microcontaminants, in general, most of the information can be transferred for that specific case. I don't know if some of the panelists want to mention something else on this topic.
No? Okay, so maybe before we go to the next question, maybe Andrea, maybe you want to comment on this work that we are doing and the importance of collaboration to make sure that actually we can obtain the impact that we are looking for, bringing all the different representatives of the value chain across the sector, particularly in Europe. And with that also, I want to take that opportunity to highlight that when we look at the case studies, if there are case studies outside of Europe, please also share them with us. What we are looking for is best practice, and best practice can be global. Yeah. But you know, Andrea, would you like to comment on that?
Yes, many thanks for giving me this opportunity. I mean, it is clear, even from the structure of this webinar, that bringing together different experts from different fields is important, because we discover areas that we couldn't imagine. I mean, in terms of importance and relevance. I mean, in addressing the contaminants, I mean, the removal of contaminants from the water. Now, something that impressed me was also the consideration about the matter that there is no one solution that can help or can fit for all. So there is the need for having, for sure, I mean, a systemic approach in the removal of contaminants, looking at what is the impact on the ecosystems. Of course, I mean, this combining and creating the synergies represents also an opportunity for assessing the validity and the complementarity of technology, which is extremely important. And something else that came up into my mind, which is important, that I see that we need, I mean, that there is a lack of harmonized data, there is a lack of standard data sets, there is the need for improving the synergic effect of combined technologies. I was also wondering about the matter, but are we ready also to run combined technologies? Do we already have, I mean, enough skilled persons or experts in order to have, I mean, on the one hand, I mean, a comprehensive outlook, I mean, on the challenge, and the other hand, the capacity of combining the technologies, combining, I mean, the different processes, and I mean, to be sure that what we use, I mean, is really organized in a way that is synergic and systemic as well. So it's a question, but at the same time, it is also, I think, I mean, a consideration for which I think that we need also to improve and to increase skills capacity and work on skills development for obtaining, I mean, substantial results.
Yeah, I totally agree with that point, Andrea, and we cannot underestimate how important it is the need for more skills and capacity building in the water sector. In Europe and worldwide, we keep hearing that, and it is not only about academic or scientific expertise. It's about the capacity building on the ground, yes, which we have to focus on, and we have to ensure that we are going to bring more people with the right skills to be able to implement anything that is needed to address the current and future challenges in the water sector. So thank you for that remark, which is great. Now we are going to go back to the audience. Angeles, before we move on to the presentation, is there any other question that you would like to highlight?
Yes, there is a question. We have more questions dealing with that the legislation only applied to NO pipe, and the technical paper is focused specifically in helping in the selection of technologies in order to accomplish with the wastewater treatment directive. However, of course, we need solutions for source control. So there is some questions on that. That is very important, and we need to highlight source control. Maybe not in this technical paper, but within Water Europe, we have other groups and we have other activities in which this is being considered. And there is also more questions about the membranes. So when we use, for example, membranes, we have to deal with the concentrates. So this is very important. Again, it's like there is no a perfect technology. So all the technologies have some advantage and disadvantage, and we need to look for the win-win situation, looking for synergies between different technologies. And we cannot use membranes if we don't know how to solve the concentrates treatment problem or challenge. All these have to be addressed in such a way that we get the more for less and for the best. As Andrea has already mentioned, we need to combine different technologies. Blanca,
excellent. Yeah? Maybe Olga wants to mention anything about the concentrate?
Yeah, sure, great, thank you. Yeah, indeed. I mean, if the membrane rejects it, it's clear that it goes to the concentrate. And as an example, we are developing a project which is called Life Pristine, where we, besides the membrane, which is a nanofiltration, tight UF, hollow fiber NF, let's say. What we apply is then an AOP to the concentrate, so that you would, if you have all the pollutants concentrated there, you can treat it with the AOP. So yeah, you have like an in situ elimination and then you can feel, let's say, safe. And we're also testing the AOP and the UV in the permeate in both. But I think that, as we said, you should look at the integrated scheme, not only, like the permeate as suggested by the audience. And the key point is the combination of technologies. There's not a unique solution, so you have to see what addresses best your case.
Okay, wonderful.
Yeah. There is another question about the ozonation and the bromide disadvantage. And this is approach, this is being studied, and we know that if we, depending on the concentration of the ozone, the bromide formation can be controlled. And here we have identified that the use of nano ozonation with that nano bubbles will be maybe an important technology to decrease bromide formation, because we can decrease the dose of ozone by 6 to 8 times, and that means that if we work below 0.3 milligrams per liter, we can reduce bromide formation. So yes, we are considering that. And there's also questions about GAC and PAC processes, and we have focused on GAC, but we also study PAC. The main difference is that we need, when we use PAC, it depends where it is being used. We are trying to avoid to discuss in this technical paper technologies that transfer the contaminant from liquid to sludge, because then we have a new problem, which is what to do with the sludge, especially in those cases where sludge is being reused for agriculture. And we are also looking into the use of GAC with biological treatment. So all these combinations, yes, we are looking for data to validate the models and to introduce it into the technical annex.
Okay, fantastic. So to make sure that we are good with the time, we are going to move back to the presentation. But before that, I wanted to say thank you to all the members of the panel who came today and join us for this discussion, and also the members of the water sector who have been contributing from wherever you are on the other side of the computer. So then we move on. And to close this section today, let me highlight the key milestones. So today's webinar marks the launch of the draft technical paper and the start of our call for case studies. Please submit your case studies using the form that we have shared on screen by the 20th of March. If you leave your contact details on the form, we may follow up with you directly to gather additional information. Nothing is going to be published without you being able to corroborate that what we published is aligned with the information that you want to share with us. We will then integrate all inputs and submit the revised technical paper to Water Europe at the end of March. And finally, we will host a second webinar at the end of June, where we will present the published version of the technical paper. Today only we gave you a few highlights of what the paper is going to include. So this is a collective effort, and we are very grateful for your engagement and everyone's contribution. Thank you for your participation on this first webinar. And now I give back the floor to Andrea Rubini. Andrea, the floor is yours.
Many thanks, Blanca, and thanks to all the speakers and who have contributed today to this webinar. I think that we got a number of key messages. And once again, I'm impressed by the matter that despite the advances, in the different technologies, it can be used from different angles. From desalination, from the green infrastructure, and other based solutions, from the more related zero pollution actions, the need for being able to build combined technologies and to run them in a way to optimize the process to reduce, to attenuate, as rightly Blanca said, the impact of pollution on our water sources becomes more and more important and needed as well. So, I think that this is also a good message because in the view of the technical paper, which will be a contribution from different expertise of Water Europe and other stakeholders of Water Europe, I think that this is an important message. Collaboration and capacity of building upon the experiences and the capacities. This touches the research innovation environment, as you said, the skill development landscape, and of course the policy, the political agenda in Europe should give us the opportunity for improving our capacity of driving the overall water management in more and more efficiently to, as you said many times, to build and to achieve a water smart society and economy. And I think that we really said a lot. I take the opportunity for just a little advisement on behalf of Water Europe. Water Europe organizes, as you know, at least 3 times, 3 flagship events. One of these is Water Market Europe 2026, which is a matchmaking event in which we call problem owners, solution providers, investors, to gather together and to start collaborating from a marketing point of view. So this year, as every year we change the topic of Water Market Europe, we concentrate our efforts on quite an important area, which is digital twins, data governance, and artificial intelligence for the water sector in order to accelerate the market deployment of innovative solutions. It will be organized in Brussels, in the NH Hotel Berlamont, so at the center of Brussels, just close to the European Commission. And this event is supported, of course, by the European Commission because it is under the umbrella of the ideation project, which is a project that looks at how we can build a digital twin system for the inland waters connected to the digital twin ocean. And the registrations are open. You can register now. I hope that we will see, a lot of experts and stakeholders at this Water Market Europe 2026. And I'm really pleased once again, to thank you. Thank you all, the speakers and the audience. My colleagues, Ioanno Pisan, Tiffany Scaff, and the colleagues from the communication pillars, Maria Miraxi, Serena Amico, for the great support in order to have this webinar being so well organized and impactful. So once again, thank you so much, and see you at the next webinar.
Okay, fantastic. Thank you all. Thank you very much,
Thank
Water
you.
Europe, for allowing us to take the floor today. Thank you.
Thank you.
Thank you. And remember to send us the forms.
Yes, sure. Absolutely. Thank you.